Hello, everyone. This is Hello, everyone. Welcome back. This is your day two tutorial recap from the Creed Machine Learning Bootcamp. If you were in the room with us, this is a chance to revisit everything at your own pace. If you're watching this for the first time, no problem at all. We will explain everything from scratch. Today is called teaching machines, and it's split into two parts. The part one is supervised learning. That is where we give the computers both the questions and answers, and it learns the patterns between them. Think of it like an exam with past questions. Uh, uh, or think of it like a flashcard with questions on one side and answers on the other side. And the part two is like this time we give the computer data with no answers at all, and we ask it to find groups on its own. And it's just like a group of Lego box instructions on the floor, or a group of balls of different color, and we ask the computer to sort it out based on the the based on what it's looking at the moment. And so and here's the fun part. We use the exact same data set for both the supervised and the unsupervised learning. First we teach the computer the what each penguins are, and then we'll figure out if it can figure it out on its own. So yeah, let's get into it. Before we touch any code, let's just get the let us set up our Google Colab, and you go to this website colab.google.com. I have this open already on my worksheet on my tab. So that's the you sign in with any account. I'm already signed in, and then before you run a single line of code, you can check the runtime and see. So for this case, we'll be using the CPU. So yeah, you save, and then you open a new notebook in Drive. Yeah. So yes, that's it. Let's quickly rename our tab to our first model, just like I mentioned in class. First model. Great. Yes. Back to the slides. So yes, supervised learning. This is like learning This is like learning with a teacher in the room. In this case, you are the teacher. You hand the computer 266 penguins and say, here are their measurements and here are the species, learn the connection. And then comes the exams where like we see how well the model answers the questions that we've given it. How well is it answering without cheating, without looking at the training data, and then how the one line of code fit into all of this. So we are going to walk through how the codes fit to into all of it. Supervised learning in one picture is like saying on the left, we have the features. These are the features: the build depth, the flipper length, the body mass. And then to in the middle, we have the model, which is a decision tree. In class, I drew how a decision tree looks like using a whether it's going to rain or not. And for our user too, I created a slide for us to see how the decision tree looks like. So like this is exactly what goes on in the mind of a decision tree model. Like humidity, is it above 70%? The cloud cover, is the sky overcast? Wind speed, is it above 20 kilometers per hour? The rain. So it is yes. If it is yes, these are the questions that comes into the model's mind. And then if it rains, this is high humidity plus cloud. If no, humid but clear sky. And if the wind speed is above 20 kilometers per hour, yes, it will say rain, dry but wind in front. If it is no, it will say dry and calm. So like that, that's how the model will keep making decisions, making decisions until it's done with the data set. Yeah, so think of it just like a tree. Decision tree works exactly the way a tree works. This is the root, these are the branches, these are the fruit, these are the branches, another fruit. So yeah, back to our slides. So yes, and then on the right we have the label. This is the answer we are trying to predict. In our case, is the species. I mentioned it in class that we'll call this Adele the singer, Ghetto the drummer, and Chainstrap the rapper. So yeah, if I'm sure you've not forgotten, and if you are new to this, so this is what we named them. So we'll be really familiar with our species. And then for the testing, the train and test, that is like the model sees 80% of the penguins with their species, and it learns the pattern. And then the test is like the fear exam. The 80% is like the question and answer of the past questions. And then the 20% is like the fear exam, the 80-20 split. That's what they call it. All the pictures of what I've mentioned just now in your head as we write the code. So we switch over to Google Colab now. Uh, let's copy this. Hold on, let's copy this. Yes, let's copy this and back to our Google Colab. Yes. So import pandas as PD. We need pandas because that's how we can use the data and the data frame. Import Seaborn as SNS. We need this for visualization. Also Matplotlib as PLT for visualizations too. The standard practice is to always try and import all the necessary libraries that you need. And from scikit-learn model selection, the train test split, which this is how we test and split our data. And then from scikit-learn tree we import the decision tree classifier. And then from scikit-learn metrics, these are the evaluation metrics for our model, which is the accuracy score, the confusion matrix, and the confusion matrix display. So let's shift enter. Yes, and then we'd see tools loaded. It's running, it's running, it's running, it's running. Yes, tools loaded. Back to our slides. The cell 2, we have we now load our data set. Most of the time, when loading the data set, the standard practice sometimes is to call the data set df. Sometimes they call it df. Sometimes you can just use the name that you'd feel appropriate. So this penguins is us calling out the data frame of the data out. And then penguins.add by default shows us the first 5 rows of the data set. See, so we have the species, we have the highland, we have the bill length, we have the build depth, we have the flipper length, we have the body mass index, we have the sex. If we do penguins.tails tail and we run it, tail would show us the last 5 columns by default. If we want to specify the number, we can put a number here like let's say 10. Show us the last 10 by default. So but if we don't specify, it will show us the last 5 by default. You can see that in the last 5 we have NAN, NAN, NAN. These are missing columns. These are missing columns in our data set. We can also do penguins.info. Yeah, and then we see. So you see, penguins.info is showing us that we have um, we have an index of 346 and then 7 columns. We have float, 4 floats, and 3 objects. Floats are decimal points, are, are numeric numbers that contain decimal points. Objects are variables of anything that are in the data set. So we have 4 columns of decimal points, and we have object of, of, of 3 in our data set. We can also do penguins.describe, yeah, which will show us the measurement of frequency in our data set, the count, the mean, the standard deviation, the minimum, the 25 percentile, the 50 percentile, 75 percentile, and then the max. But for the sake of our time, let's stick to add. Yes, and move and proceed to the next slide, to the next code. Um, Yes. So in collapse cells 3 and 4, pick clues, split study versus exam. So there's something unique that cell 3 is about to do. There's something unique that cell 3 is about to do. It's going to drop and remove penguins with missing measurements. This part of it is called data cleaning. Data cleaning. So we want to clean our data to remove the missing measurement in our data set. You see 343 penguins ready, and initially we had in our data, in our penguins.info, penguins.info, we had 343 here, and now we have 333. Do you understand? So it means that all the missing columns, all the missing columns, all the rows with missing measurement has been dropped. So yes, to cell 4, let's proceed to cell 4, which is the train, test, and split. Yeah. So this is one of the most important steps in machine learning. Why is it important? We are dividing the 344 penguins into 2 groups. 80% goes into our training and 20% into our test data. The test data is sealed away and the model never touches it until exam time. Just think of it that you go to school every time, but you do tests, but you do exams and the likes for just like a week. But think of it like if the teacher gave you practice papers and then use the exact same questions, you could ace it without actually understanding everything because you are working at it from, you are approaching it from memory. You're approaching it from memory. You would just be memorizing, and then it will look like you are performing well, but you are actually not. So the train test split, it stops the model from cheating like that. It has to perform on penguins it genuinely has never seen. The the random state here is just like you shuffle it the same way every time. So your results will match our own. So let's you can press this button to run the cell, or you press Control Shift, or you press Shift Enter to run the cell. So training penguins 266, test penguins 67. Hold on to these numbers that you are seeing, hold on to the thought, and then you'd realize that this X train, X test, Y train, Y test. These steps is very important, just like I mentioned earlier. So let's move to cell to our cell 5. Yes, this is where we we train, we bring out our model. I'm moving quickly because this is a recap, and because you can follow at your own pace, and that's why we are taking time to explain. Just like the importation of the library that we did earlier, we specified that we needed the decision tree max classifier. So the max depth here is the max depth here means that the tree can only ask 3 questions before it moves into making a decision. Without that limit, it will just memorize every single training penguins rather than learning the pattern. So this max depth is like a constraint, like you must not go over this line, oh, you must not do more than this, oh. And then if you, because it will not do more than that, it is forced to learn. And then I explained this random state earlier. It's just a shuffling. It shuffles just like a pack of cards. It shuffles, it shuffles, it shuffles. And then the model dot fit line, this is the line where the learning actually happens. This is where the learning actually happens. And then the computer looks at the 266 penguins that we have, that we have, their measurement, their species, and figures out the rules connecting them. It takes just about a second. You can see how important machine learning is. See, in less than a second, model trained. Imagine that you give me this data set and you tell me to identify the patterns. I'll probably still be I'll probably still be I'll probably still I'll be finding it difficult now to reach this stage and be trained to identify the patterns already. But in seconds, we can see that our model has already identified the patterns, and it has been trained quickly to answer the questions. So let's copy cell 6. Let's copy cell 6 quickly and then see the predictions. Shift enter. We have an accuracy of 99%. So this is the exam model, which is like for example in this cell 5 where it's saying model trained. The second, just that second that I just trained it is something that like in the earlier times it would take like days to do manually, and it's now getting done in seconds. How brilliant is machine learning? You answer the question, you know the answer to that. So cell 6, this is the model dot predict. Um that is, the model takes the 67 exams that we've prepared for it, the ones the model has never seen, and guesses the species for each one. Then the accuracy score, this is an evaluation matrix. The accuracy is like the guess to the real answers. How easily does our model guess the real answers? And then when we run the cell 6, as you are seeing the 99% accuracy, it is good. But I remember that in class, someone mentioned that I asked that is 99% accuracy good? And then she said no, that it should be 100%. And I'm sure that you have some questions that you want to answer, like why can't it be 100%? You will need to stay tuned for day 3 to find out more about the evaluation metrics, where we will like take time to really understand more about what evaluation metrics actually mean. And but without dwelling too much on that, the cell 6, we see the accuracy, which is like we expect somewhere around 95% in, and then we have 99. which is actually good. Um, let's go back to the slides and then we'll break it down. Um, yes, let's print our confusion matrix. One of my students, she liked this part a lot, and then she mentioned concussion matrix. So yes, let's talk about the confusion matrix. Let's control and run that and see. So this concussion matrix, oh yes, confusion matrix. This confusion matrix, this is it shows us exactly where the model got confused. This is a grid. We had 99% accuracy, but where? That doesn't the evaluation metrics alone does not tell the full picture. But we use evaluation metrics and other things to support decision making. Remember that we imported something called confusion matrix display in our first cell. This is it showing up now. So this is the Adele, the singer. The model got Adele, the singer, correctly, and then it did not misrepresent Adele, the singer, at all. The model struggled a bit with Chin Strap, the rapper. It was able to predict 12 and then misidentified one, which was probably maybe Adele, which was Adele, the singer, and then Gento, the drummer. The model identified all of Gento, the drummer, correctly. You see, the first part draws a confusion matrix, which is like it is really fun. It is really fun. The confusion matrix is really fun, and we see that the Gento is the model struggled only with the wrappers. So yeah, now that we've seen that, let's now analyze. Let's go back to our slide and talk more about the evaluation metrics. So yes, how do we know if it is any good? Now that we've seen the result, the accuracy is the simplest one. We can see that out of all the penguins, what percentage did we get right? 60 correct out of 67 would make 90%. So we probably got 64 correctly out of 67, which gives us like the 99% that we got. And then the confusion matrix, it gives us the full picture. The full picture. The rows are the real species, just like I mentioned, and the columns are the guesses. So big numbers on the diagonal, good. Off the diagonal, mixed up. Like just like I explained here, these numbers, these are good. Off the diagonal, mixed up. Do you understand? These are good. These are mixed up. These are what? Good. These are mixed up. So we didn't use precision and recall. So but in the day three, we are going to talk more about precision and recall as an evaluation metrics. So yes, that's that about supervised learning. But for context ahead of day two, precision and recalls are for situations where some mistakes are much worse than the others. Precision asks when the model said Adele, how often was it actually right? You understand? Which are like the false positives and false negatives. And then in recall, it asks that of all the real Adele's the singer, how many did the model actually find? Recall is really important in medical settings because imagine someone having headache and then they are being told that they don't have headache when they actually have headache. Which one is worse? Or someone having cancer and they are being told that they don't have cancer when they actually have cancer. So your evaluation metric depends on the business context, because this matters a lot. Recall matters a lot in medical settings because missing a real case of a disease is a very different kind of mistake from flagging a healthy person. So here is the question for you to think about. Imagine a model that always guesses Adele the singer right, no matter what. Adele is about 44% of this data set. So what model would get 44% accuracy for free without learning anything? Why is that a problem? Think about that. Thank you.